In this video, we're going to talk about some things from sections P3 and 1.4. And the first thing that we're going to do is review what a perfect square is. So if we square the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., then we get these numbers that are perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And we can use this chart in reverse to calculate square roots. So for example, the square root of 16 is 4 because 4 squared is 16. So first we're going to evaluate some simple square roots. The first one is square root of 64. So looking at this chart, 64, the square root of that is 8. Because 8 to the second power is equal to 64. Now for B, notice that we have a negative sign in front of the square root. In order of operations, square rooting is on the same level as exponents. So we would do the square root of 49 first, and then we would make the answer negative. The square root of 49 is 7, so my answer here would be negative 7. For C, if we have a fraction, what we can do is break up the square root so that it's over the numerator and denominator separately. And then we can take the square root of each. The square root of 1 is 1, and the square root of 4 is 2. So the answer here would be 1/2. For D, what they want us to do is add 9 plus 16 and then take the square root of that answer. 9 plus 16 is 25, and the square root of 25 is 5. Now notice how that's different from E, where we have the square root not over the whole thing, but just over the 9 and the 16. In this problem, we take the square root of each number first and then add them together. And you're going to notice that we're going to get something different from what we got in part D. So the square root of 9 is 3. And the square root of 16 is 4, and 3 plus 4 is equal to 7. So not the same thing as 5. So you can't break up addition, break up the square root over two things that are added together. So next you should look at checkpoint number 1. Do this in your notes, check your answers, and then move on with the rest of the video. Now we have a question here. It says to consider the square root of negative 25. Is there a real number whose square is negative 25? And the answer to that is no. So if we think about positive 5, 5 times 5, that's positive 25. If we were to square negative 5, that would be negative 5 times negative 5, and negative times negative makes a positive. So that's also positive 25. There's no way to multiply the same number by itself and get a negative number. In order to multiply to get a negative number, you have to have one positive number and one negative number, and then the two numbers cannot be the same. So we say that a square root of a negative number is not a real number, and we're going to come back to this in a few minutes. So we have this rule that's called the product rule. Now we saw the examples before where we can't break up addition into separate square roots, but it does work for multiplication. So if we have two things that are multiplied, we can separate them and write the square root over each, and this helps us to simplify square roots. So looking at example 2, we're only going to do part A here because we're only going to do this with problems where we're looking at the square root of numbers and not problems that have variables in them. So for A, it's the square root of 500. Now what I want to think about is, okay, what is a number that 500 can be divided by that is a perfect square? And so I can go back to page 1 and use the chart of square roots to help me. I want to try to think of the biggest number I can that's a perfect square. And the one that I can think of right now is 100. I know that 500 is equal to 100 times 5. And I'm going to write that with the number that's a perfect square first, and then the other number second. So 100 is a perfect square, so I write that first. Then I can break up the square root of 100 times 5 into two separate square roots, square root of 100 and square root of 5, and those are multiplied together. Now, square root of 100 is a perfect square. I can simplify that, that's equal to 10. Square root of 5, not a perfect square, so I just bring that down, square root of 5. So for these simplifying problems, you always should be able to take one number that is a perfect square, take the square root of that, and then have one number that's not a perfect square, and that just stays under the square root. So we have 10 times square root of 5 as my answer. So next you should try checkpoint problem number 2. Do this in your notes, just do part A, and check your answer, and then move on with the rest of the video. So next we're going to go back to negative numbers, and as we said before, the square root of a negative number is not a real number. So one way that we kind of can get around that and still work with them is using these things called imaginary numbers. And we use what's called the imaginary unit, which is the letter I. It's the number so that I squared equals negative 1. Now remember, there's no real number that you can square it that it's equal to negative 1, because I'd have to have one positive and one negative to multiply to equal a negative number. So that's why we say it's not a real number, it's an imaginary number. And essentially what we do is if we have the square root of a negative number, we consider that as negative 1 times the positive number, and then the negative 1 comes out and becomes an I. And so we write the I in front of the square root and then have the square root of the number. So we're going to look at some examples here. The first one is actually a perfect square because it's the square root of 36. So that's a little bit different too. So we can think of negative 36 as negative 1 times positive 36. And then, using the same rule that we just saw, we can break that up into two separate square roots. Now I know the square root of 36 is 6, and square root of negative 1 we're going to replace with I. So my answer here is 6I. If we have a whole number followed by I, or with an I, then we write the I after the whole number, kind of like if it's just a regular variable, it comes after the number. Same thing for number 2. 64 is a perfect square. Square root of 64 is 8. So I would write 8, and then I would have I to represent that negative sign under the square root. So the answer to this one would be 8I. If the number is not a perfect square and it can't be simplified, then all we do is write the I in front of the square root. So 23, if I try to think about a number that 23 could be divided by that's a perfect square, I can't come up with anything. 23 can only be divided by 1 in itself. So there's no way to simplify the 23 part. All I'm going to do is take the I and put it on the outside. That sort of represents taking the negative sign out from under the square root. So I'm kind of going like that. Negative sign comes out and turns into an I. For number 4, this one I can simplify because 18 I know is equal to 9 times 2. So the easiest way to think about this one is to break it up into negative 9 times 2. And then I can think of that as two separate square roots. Square root of negative 9 times square root of 2. Now the square root of negative 9, kind of like we did in number 1 and number 2, I'm going to write that as 3I. Square root of 9 is 3. Negative sign becomes an I. And then square root of 2, I can't simplify it, so I'm just going to bring that down. So, if we have a situation where we have a square root that's simplified and an I, the I comes after the number in front of the square root but before the square root, so it goes in between these two. So for square roots, I comes first. For numbers, I comes second, and then I goes in between those two.